Here is a triplex pump. It's quite a bulky item. That's why we've got a lifting eye on the top over here for lifting it into position. Now don't worry about this side so much, we'll get to that in a moment. Let's come over to here and we'll run through some of its main parts. First, we've got the plunger over here. As I mentioned, it may also be a piston. Plungers are used for higher pressure systems. They're effectively cylinders, as you can see from this angle. We've got the bore. I'll back it up a moment, I'll be able to get in there. We've got the bore of the plunger, the diameter of which is indicated now. And then we've got the length of the plunger, which is indicated now. The crankshaft is similar to what you would see in a car. They have a central rotational axis, and that allows us to get a stroke of a piston. You see here, if we go from this position here and we go ahead, that represents a single stroke. If we were to go back again, that represents another stroke. If they all sucked and discharged at the same time, the pump would vibrate excessively and we get large pressure pulsations within our system. Imagine for a moment those bearings get so hot that they ignite that flammable process fluid. We're then going to get a pump that essentially explodes. You may think that I'm going into the creative realms here and doing a work of fiction, but that's exactly what happens on large marine two-stroke engines. They have something called a crankcase explosion. On smaller two-stroke engines, you can pressurize the crankcase, and you often will. If we get a low level, we're going to get an alarm. If we get a low level, well, that is to say a very low level, we trigger a shutdown of the pump. So that's how we can protect the pump, by measuring the pressure of the lubricating oil system and ensuring that if it is low, we can at least activate an alarm to alert engineers, or if it's very low, we shut down the pump and protect the pump.